Okay, so I think what I'll do is I'll just start from the beginning and I'll just kind of summarize everything and then make notes at what parts you have questions on or what part you want more explanation on. So like the first thing you learned was just how to add and subtract polynomials. So like if I went 4 plus 2n squared plus, and this is the type of problems you'll see on the test. Whoops, that should be a squared. I'm just using the test review problems that they provided me. So they tell me this is what the test looks like. So anytime when you see like any problem like this where there's not an equals, then you want to look to and you want to ask yourself, what are they asking me to do? What they're asking you to do will be right here. So if there's a plus in there, then you're going to add like terms, just the things that are alike. If there's a minus in there, you're going to subtract the things that are alike. Now remember, if they're alike, they have to be exactly alike. Like an n cubed and an n squared are not exactly alike. They have to have the same letter, same exponent. Okay? If there's nothing in the center right here, then that means you're going to multiply. So we're going to kind of step through that. So like this kind of a problem, these parentheses don't mean anything because with addition, you don't really need parentheses. So you can think of it as 4 plus 2n squared plus 5n squared plus 2. So the things that are alike are the plus 2n squared and the plus 5n squared. And then the 4 and the 2 are alike because they don't have any letters. And so you can put the 4 and 2 together and call it 6. And you can put the 2n squared and the 5n squared together and call it 7n squared. So because it's a positive 7n squared, I'm going to write plus n squared. That's as far as you can go because when you're adding and subtracting, you have to have exactly the same type of terms to be able to put them together. So you're not solving for anything because there's no equals. Okay, so like a tricky one might be like this. Negative 2k squared plus k to the third minus 2 plus 2k cubed plus 1. Okay, so the reason why this might be a little bit tricky is they're trying, if they give you something like this, they're trying to see if you understand that this does not go with these. There's no other term that has a K2 on it. And so that means all you can do is just write it in the answer. The minus, all the signs in front of the numbers go with the numbers. So they will try and trick you that way too. Like, let me make this a minus. So now if you're going to look at, let me change colors. Let's say you start looking at the K cubes. Notice how I grouped it with the minus in front of it? That's important. Okay, so if I put these two together, this is really a 1 right here. So minus 1 plus 2. The reason I know it's plus 2 is because there's nothing out here in front of the 2, so it must be a positive 2. It's just assumed. So a minus 1k cubed and a plus 2k cubed, when you put those together, minus 1 and plus 2, that makes negative 1 or minus 1. So you could just write minus 1 k cubed. Notice how I said negative and minus and I kind of just said them both at the same time. It doesn't matter. Okay, what you want to avoid is having two signs right in here. You just want one sign in there. So if it's a positive 1, put a plus. If it's a negative 1, put a minus. And then you can see, let me change colors again. This and this are alike because they don't have any variable with them. So a minus 2 and a plus 1, and if you get confused, take your calculator and just go, but don't use minus, use a negative. Go negative 2 plus 1. And it'll tell you it's negative 1, so you just write minus 1. This is as far as I can go because nothing else is alike. Okay, so that brings you through the add and subtract ones. Then we did ones like this. And you know it's multiplication because there's nothing right here. So if there's nothing right there, that means multiply. You can't add 2k and 6 together because they're not like terms. But what you can do is you can use that distributive property and you can multiply the 2k squared through. So 2k squared times 2k, if you have 2k squared looks like that, and if you multiply it times another 2 and a k, then you can see that that's going to be 3k's, so it's going to be 4k cubed. If you get confused, write it out like this. That's the best way. And then 2k squared times 6. Even though these are different, these aren't like terms, you can multiply unlike terms. And that's where it gets confusing. You can't add and subtract them if they're not alike, but you can multiply and divide whenever you want. So the 2k squared times the 6, so think about it this way. 2k times 6. Well, the 2 and the 6 will make 12, and the kk will make k squared. And it will be positive, so positive 12k squared. Okay. Oh, I should probably talk about subtraction of the polynomials too. We did those type. But before we go any further, I probably should have gave you a subtraction one on polynomials. If I said 4a cubed plus 2a squared minus 1 minus 10a cubed, ooh, that doesn't look good. Let's pick a different letter or a different number. 7a cubed minus a squared. Since this is subtraction right here, and these parentheses are here, you have to pay attention to that. With addition, it didn't matter. We could just take the parentheses out. But with subtraction, you're subtracting the 7a cubed, plus you're subtracting this minus a squared. Okay, so if you write it without the parentheses, that's the best way to start. And if you subtract 7a cubed, it just looks like minus 7a cubed. But if you subtract a negative a squared, it turns to a positive a squared, because you're subtracting a negative. And subtracting a negative is just going to be like adding. So now that the parentheses are gone, so they will test you specifically on this concept to see if you can distribute that through. They will purposely put negatives in there. Okay, so now once you distribute all that through, then you can go ahead and add your like terms because everything is add and subtract and there's no more parentheses left. So 4a cubed, notice how I'm grouping the minus with the 7. Those two are alike, so I can put those two bubbles together. So 4a cubed minus 7a cubed makes a negative 3a cubed. Notice that my variables or my exponents aren't changing because I'm just putting things that are alike. It's saying like, you know, 4 red cards and I don't know, if you have negative 7 red cards or whatever. But they're just things. They're just a cubes. So then you can put 2a squared together with 1a squared, and that makes 3a squared. Okay? So if you force yourself to like distribute that through, that would probably be good. Okay, so back to multiplication. So like when you're watching this, if you go, man, I'm going to screw up on the minus part. I need some practice at that. Whatever you want practice at, write it down while you're watching this, and then I can give you some practice problems to like, you know, strengthen it in your head. Okay, so we did distributive property, right? So let's do one more distributive property. Like if I have negative 3a times negative 5a plus 2. So I know this is distributive property because remember what I said about there's no equals, so I'm not solving anything. But I want to know, am I adding, am I multiplying, what am I doing? You want to look where the parentheses are. And since there's not two sets of parentheses, you want to look where what's between whatever in the parenthesis. So if there's nothing between the negative 3a and the parenthesis, there's no sign there, then it's automatically times. So I'm going to multiply this through. So I have negative 3a times a negative 5a. So that makes 15a squared. Notice when I multiply, the exponents change. I always, when I teach middle school, I always make them write it out. And so they see that they're multiplying those and they know a times a makes a squared. And then 3a, negative 3a times 2. Negative 3a times 2. The negative 3 times a positive 2 makes a negative 6. So I'm just going to write minus 6. Because I don't want to write a plus negative. That gets too confusing. And then it has an a. Okay. Then we went and we started foiling. So like 4a plus 3 times 2a minus 6. And I just made this up. Remember, okay, so there's no equals. So you're going to go, okay, I'm not solving anything. But what am I doing? My dog's whining. So you look in between the parentheses. And since there's nothing there, it means we're timesing. So it's kind of like, I don't know, if you're good with the FOIL, then don't listen to this. But if you're really struggling with that whole FOIL thing, it's like having this 4a and distributing it through here, and then having this 3 and distributing it through here. So it's basically the distributive property twice. Okay, so I'm going to start with the 4a, and I have 4a times 2a. Remember, when you multiply, a times a makes a squared. So that's 8a squared. And then 4a times negative 6. Make sure you're seeing that bubble. And if you're struggling with that, my advice is like, before you start the problem, maybe like bubble all the terms. And when I teach middle school algebra, and sometimes it's just so, we spend probably a week on this, where you guys are getting it for a day, and what I just tell them is I tell them the bubbles go together, and then they're done, you know. So the 4a bubble times the minus 6 bubble, well, 4 times negative 6, now notice I'm saying minus and negative. Okay, if you think about it as a bubble, then you don't see it as a minus. You see it as a negative 6. You see it as a bubble. So 4a times negative 6 makes negative 24a. So I'm going to write minus 24a. I'm going to change colors here. So now I'm done with that 4a bubble. So now I'm going to take the 3 and distribute it through. So 3 times 2a makes positive 6a. And 3 times negative 6 makes negative 18. Now, almost always, these two will combine at the end. And this is where I think a lot of people struggle, because they're like, I don't know when I'm supposed to be saying a squared or just a. And it's when you're multiplying, the exponents will change. That last step is just combining. When you combine like terms, they stay exactly alike. So since 24a and 6a are alike, I put them together and they make negative or minus, whichever you want to call it, 18a. They just stayed in a. So it's just like putting 24 apples and 6 apples, like taking away 24 apples and adding 6 apples. You're in the whole 18, but they're still apples. And then I bring all that down. Okay? So you learned how to FOIL. The reason you learned that is they were trying to get to the point where you understood what a quadratic looked like. So this is a quadratic. The reason it's a quadratic is because it has that squared. And so we'll get to that. So they definitely will have some problems on using FOIL and also that distributive property. Then let's see. greatest common factor, they'll have some on the greatest common factor. So if I give you like 3a squared plus 6a to the fourth, and I ask you for a GCF, that's just the biggest number that goes into them. So what I always look at the numbers first and then the variables. So what's the biggest number that they have in common if you started multiplying or adding by them, whichever you want to think of it. So like 3 is the biggest number that goes into both of them. Remember, it's got to be common and it's got to be a factor, meaning that it has to go into them. So their greatest common factor is 3 because it's the biggest number that divides into them evenly. Then if you look at the variable or the variables, this one has 2 A's and this one has 4 A's. So if I wrote it out, this is what it would look like. So remember, common means that you're sharing something. So what's the greatest number that they share? They share 2 A's. So then it's a squared. So let's see. And I can give you problems if you're struggling with the greatest common factor. I can give you more of those. So far we've covered simplifying polynomials, adding, subtracting, and multiplying. And we've covered multiplying or using the FOIL and the distributive property, and now a GCF. Okay, so now we'll cover, let's see, simplifying. So then we went to simplifying. So like if I say 6x cubed times 2x squared. Since a 6x is in these parentheses, I would say don't memorize the rules that the book does. You know how they memorize the rules when you add exponents, when you multiply exponents. That's really dangerous when you're learning it this fast. I wouldn't do it. I would say, okay, so this 3 means that there's 3 sets. So I would sit there and go 6x, 6x, 6x. This 2 means that there's 2 sets. So 2x, 2x. So they're being multiplied together because there's nothing between them. And really these are all being multiplied together. So now I can take all my whole numbers. So 6 times 6 times 6, brain fart, 18 times 2 times 2, so 18 times 4, 72. So it'd be 72, and then count your x's. 1, 2, 3, 4, 5, so x to the 5th. We did these to the 0 power. Now if you forget what the 0 power means, just take your calculator and go -5 and then take it to the 0 power. You should have a square root button or a little mountain button like that, just to see what happens. Anything to the 0 power is just one whole. And so then this whole thing equals 1. But if it was like this, then this would equal 1 whole, but you'd still have the x there, so that would equal x. So these are 2 separate problems. So the reason this one equals 1 up here is because this whole thing is taken to a 0 power. This one, only the bottom one, only the 5 was taken to the 0 power, or the -5. I should have put parentheses around there. So then we went into division, something like -2x over 4x to the 5th. And the book showed you, oh, memorize the rule, subtract. Don't do that. If I were you, I would just write it out first. 1, 2, 3, 4, 5. -2 divided by 4 makes -1/2. And then these x cancel, and there's 1, 2, 3, 4 at the bottom of the fraction, so you put them at the bottom. Something like this, let's say you have 6 x to the 4th, x, y to the 3rd, y squared. The easiest way to do it, I mean, the shortcut's an easy way, but if you don't have those memorized, it's dangerous on a test. So just draw them out. Remember to leave them, like if they're on the top of the fraction, leave them on the top of the fraction. If they're at the bottom of the fraction, leave them on the bottom. Then the 2 and the 6 simplify to 1/3. And then the x over x, those simplify, those are gone, that's gone, that's gone. You have 3 x's on the top, so they stay on the top. You have 1 y on the bottom, so it stays on the bottom. Okay, let's see. So I'm going to try and take one out of the practice. Then we had some negative exponents. Okay, my advice on negative exponents, well, let me make this, I'm going to change this to 2 over d to the negative 2. So all negative exponents is that it's either a fraction or a whole number. If I were you, I would just make a big huge fraction mark. Okay? If you see a negative exponent, right now it's just on top of a fraction because there's no fraction there. So you're going to move it to the bottom and you're going to make it positive. I should have left the 8 there too. The 8 is just left there, so I'm going to leave it on the top. V to the negative 3. So it's not a fraction up here where I circled it, so that means I need to make it a fraction. And the exponent becomes positive. The negative 4 is up there, so I'm going to go times negative 4. D to the negative 5th, so I'm going to bring that down. V to the negative 5th, so I'm going to bring that down. The 2 is a numerator, it's on the top, so I'm going to go times 2. And this d to the negative 2 was under the line, so I'm going to move it above the line. If you just go through and change all your negative exponents, notice I didn't change the negative 4 because that's a negative number, it's not a negative exponent. If you go through and change all your negative exponents and you flip them, wherever, if they're on the top, you flip them to the bottom. If they're on the bottom, you flip them to the top. Makes everything positive. Then you can go and draw it all out. So 8 times negative 4 times 2 is negatives. 8 times 8 is 64. Negative 64. And then you have 2 d's up there for the d squared. Down below you have 3 d's, 3 v's, 5 d's, and 5 more v's. So one of these d's is going to cancel with a d down below. One of these d's is going to cancel with a d down below. And you're going to have negative 64 on the top. And then you just count it up. Your v's, you have 5, 6, 7, 8. You have v to the 8th, d to the 1, 2, 3, 4, 5th. Okay. Then we did scientific notation. So if I asked you to take this number, which is just a normal number, and give it to me in scientific notation, then scientific notation is when your first number is a number that's less than 10. So I would have to move the decimal to right there for this number to look like it's a number less than 10. And then it would be 3.12. Times, it's always a 10. And then the little exponent up here is how many times you move the decimal. So I move the decimal 1, 2, 3, 4 times. And so think about this. You're going to ask yourself, is this a positive 4 or is it a negative 4? Well, you can always, in your calculator, take 3.12 and go times 10 to the fourth. If that gives you the original number that we started with, then it's positive 4. If you go 10 to the negative 4 and it gives you that, it's a negative 4. In this case, it would be negative, because if I multiply by negative exponents, things get tiny. So if I take 3.12 and I multiplied it by 10 to the negative 4, it should get tiny, and it was a tiny number when it started out with. Then they will have, let's see, they'll give you a scientific notation. So maybe 6.237 times 10 to the fifth, and they'll say write it out the extended way. They'll say the standard notation way. So you can just take your calculator and multiply that, but they'll probably, I'm assuming they're probably going to make the numbers so big that your calculator won't hold it, so that you can't do it on a calculator. But all this means is if you're multiplying by 10 to a positive fifth power, it means the number's got to get big, and that decimal's got to move 5 times. So which way would the decimal go on 6.237 to make it big? It's going to go to the right. And so you just make the decimal move 5 times. 1, 2, 3, 4, 5. Just make sure you don't put it in the original spot. Just make sure on the test you only have 1 decimal. So that becomes your answer. If I had this, then I know the number's got to get smaller because it's a negative exponent. So my decimal's got to move to the left, because that's how numbers get smaller when the decimal's in front of them. So if I move the decimal 4 times, it's going to look like this. Notice I only had 3 zeros because I had to move past the 3. And that was 1, 2, 3, 4. So then this is my answer. Let's see. They try to trick you by having a negative number. 2.76 times 10 to the negative fifth. Well, again, ask yourself if this is going to be a small number or a big number. So a negative exponent is a small number. My decimal's moving to the left. That negative right there, that just means the answer's negative. So shove a negative out there and go 0.0000276 and you're done. Let's see. Then we went to simplifying radicals. So if I had like the square root of 60, you want to try and think about how can I break 60 up? What times what makes 60 where I might get a perfect square? Well, definitely 6 times 10, but neither one of those are perfect squares. So if you think about 60, you can do it a couple ways. You can sit there and just try to think about what times what makes 60, like 15 and 4, and go, oh, okay, well, 4 times 15, and you know that the square root of 4, that's the same as separating them. So you know the square root of 4 is 2, so you could call this 2 square root 15. If you couldn't get there, if you're like, I don't know what makes 60 and I'm really getting frustrated, you can break, I don't know if you remember how to do this, but you can make a factor tree. Oops. Can't remember if we covered factor trees or not. Once you make a factor tree, you can see that there's 2 2's, and so that's where that 4 comes from, and then a 3 and a 5 make 15. They tried to see if you understood that if you had a fraction and both of them had the radical, can you simplify it? Well, what times what makes 8? That's perfect squares. 4 times 2 does. So I can write this like this. And what makes 12 that's a perfect square? 6 and 2 don't help you because neither one of them are perfect squares. But 3 and 4, so I can go square root of 4, square root of 3. You can either at this point see that these two cancel, but if you didn't, you could turn them into 2's. And then see that they cancel. Square root of 2 over square root of 3. And that's as far as you can go. They had ones like this, where maybe like that maybe. And they had the square root symbol going all the way down and all the way up. They're trying to test to see if you know that's the same thing as doing this. And then again, you got to simplify as much as you can. The only things that make 15 are 3 and 5, and neither one are perfect squares, so you have to leave that, the square root of 15. But square root of 25 is 5. So then that's simplified all the way. Let's see, we also did it with variables. So like square root of 135, a cubed, b to the 5th. So if I broke that down, what times what makes 135? 5 goes into that. 27 times 5 and 27. Neither one of those are perfect squares. 27 breaks down to 9 times 3. So 9 is a perfect square. Okay, so this you could break this down to square root of 9 times 5 times 3. Now these, you want to, since it's a square root, you want to break them down into 2s. So a cubed is the same as a squared times a. b to the 5th is b squared, and another b. So if you start taking the square root of things, square root of 9 is 3. Can't do anything with the 5 and the 3, so I'm going to make a radical out here so I don't forget. 5 and 3 is 15. So, okay, so I took care of that. Then square root of a squared is a. Then there's a single a I can't do anything with. B squared is b squared is b, and I can't do anything with that b. So my final answer is 3ab squared square root of 15ab. Then we went into solving the radicals. So now you're into equations. So if I went like this, to solve an equation with a radical, you want to isolate the radical, which just means that if there was like a plus 5 over here, you'd want to subtract 5 from each side first, but there's not, so you don't have to worry about it. Once you isolate the radical, once the radical is on the side, one side of the equation by itself, to get rid of a radical, you square, and whatever you do to one side, you do to the other. So the square root and the squared cancel, and you get x minus 1. And on the other side, 3 squared is 9. And then it's just, you know how to solve an equation from there. X equals 10. Okay, then let's see. They got harder, like this. So now there's a radical on both sides. So I'm going to square both sides. That's going to give me 9 minus b equals 1 minus 9b. I'm going to get all my b's to one side and all my numbers to the other. So I'm going to add b here. That's going to be negative 8b. Then I'm going to take the 1 over, and I'm running out of room. So 9 minus 1 is 8 equals negative 8b, and then divide by negative 8. And get b equals negative 1. Okay, then, phew, they even got harder than that. Like the square root of 2x minus 7. You've learned a ton this quarter. Never realize it until I start looking at everything. So again, you want to see if the radical is by itself, and it is. If it's not, you're going to move whatever is by the radical. So I'm going to square both sides. But remember, it's this whole thing squared, so this is why it's getting a little bit harder. So the left side equals 2x minus 7, but the right side, you're going to have to FOIL it. That's a 3. So you got 2x minus 7 equals x squared minus 3x plus 9. So x squared minus 6x plus 9. Since there's an exponent, that means you've got to solve for 0 and then factor it. That only happens when there's an exponent. So when there's an exponent, there is a large chance there's going to be two answers. So I'm going to pull the 2x over. And I'm going to get negative 7 equals x squared minus 8x plus 9. I'm going to add 7 to each side. Okay, so I pulled everything over to the right. I solved for 0. Okay, so when you were doing this, you didn't understand how to graph yet, and the way it all kind of connects is when you graph, this is going to be a parabola. And so you get these two crosses at the x-axis. And so that's why you're putting a 0 in where the y used to be. Okay, so I'm going to factor. And I'm going to look for something that multiplies to 16 and adds to negative 8. So that's negative 4 and negative 4. Remember, I'm looking to see what makes it equal 0. So this would be, a positive 4 would make x minus 4 equals 0. So I know 4 is one of the answers. And then since this one's the same thing, you're just going to have x equals 4. But if it wasn't, you'd have two answers. Okay. You had one that looked like this. You don't want to square both sides yet because you didn't isolate the variable. So x minus 5 equals, there's my dog whistling. Then you're going to square both sides. So you have 3x minus 11 equals, and again, this part's going to be x minus 5 times x minus 5. Okay, so you're going to have to FOIL that. I'm going to go ahead and do it in my head. Minus 10x plus 25. Okay, then you're going to pull the 3 over, the 3x. And add the 11, and this is getting super messy, sorry. And you get x squared minus 2x plus 25 equals 0. And then you want something that multiplies to 25 and adds to negative 2, and I must have screwed up somewhere because there's no numbers that do that. Took 5 away. Minus 3, minus 13. Oh, this right here, there we go, there's my error. When I added 11, I should have added it right here. And, wow, I really messed up. There we go. That's what I get for making it all messy and squishy. 13x plus 36. There we go. And then you're going to look for what times what multiplies to 36 but adds to negative 13, and that's going to be 9 and negative 9 and negative 4. And then, oh, and the last one I didn't check to see if it worked. So when you set this one equal to 0, you're going to get x equals positive 9. When you set this one equal to 0, you're going to get x equals positive 4. But make sure you plug those back into the original equation and see if they work. I think this one didn't work. I think this was a problem on the quiz. And so you always want to make sure they both work, because sometimes you get that answer that isn't really true. Okay, then you had solving for variables. Let me know, there's so many different types, just let me know if you want me to go through that one for you. Okay, so then you had factoring, so that's kind of what we were just doing, like if you had x squared minus 14x plus 45 and I asked you to factor it, that's breaking it down to what times what makes that. Remember that it multiplies to 45 and adds to negative 14. So 9 and 5. So you just got to make sure your signs are right. if you're on the test, I would tell yourself, I would make yourself write this down if I were you. And then I would give myself the number, so I think it's 9 and 5. And then say, okay, well, they got to add to a negative, so I need both negative. And then double check, do they multiply to a positive? That's 5 and minus 9. Just watch your signs. You know, if you have time on the test, I put a star by these and go back to them and foil them and see if you get back where you started. Like I could sit there and foil these and go x squared minus 5x minus 9x plus 45 x squared, combine these, minus 14x plus 45, and make sure that this is exactly what I started with. Okay. Then, let's see, by factoring and using zero property multiplication. So they went into more, where they made it an equation. Nothing different. Just still factoring. So what multiplies to negative 55 and adds to 6? So what times what makes 55? 5 and 11. Ooh, 5 and 11, because you're going to have to subtract one because it multiplies to a negative. So it's either negative 5 and positive 11 or positive 5 and negative 11. Well, remember they have to add to positive 6, so it must be this one. So x minus 5, x plus 11. The difference of this and the problem I just did before is this one's an equation, so it's asking you for a final answer. So what's going to make this part 0? A positive 5, right? What's going to make this part 0? A negative 11. So you're answering it all the way. So that's the only difference. Then they'll try to give you some that aren't in any form, like, well, they actually don't do that. I thought you might have to set them equal to 0, but it looks like they're all, oh yeah, okay. So if I had like x squared plus 7 equals 8x, we had this one on a quiz too. Set it equal to 0 first before you start. So minus 8x minus 8x. And then remember the quadratic is always the squared first, then the one with the x, then the one without any variable. Then factor it. What multiplies to 7 and adds to negative 8? Negative 1 and negative 7. And then because it's an equation, you got to solve it. So x equals 1, x equals 7. Okay. Then came the quadratic formula. So that was the negative b plus or minus square root 4a, I already screwed it up. Plus or minus b squared minus 4ac all over 2a. So you took an equation, and what the quadratic formula does is exactly what we were just doing, but you use it because not all equations are easy to factor. So like the equation that we just did, that was x squared minus 8x plus 7. I could use the quadratic on this and I would get the same answer. They will have problems. I'm imagining they'll have problems that say you have to factor it, so that means you have to put it into those two sets of parentheses, and then some where they'll say use the quadratic formula. So they're both doing the exact same thing. They're just finding where, if you were graphing them, they're finding where the equation crosses the x-axis. That's all it is. Okay, so let me know if you need help, like running yourself through the quadratic formula, because I can do some of those if you need help. Basically what you got to do is just set your equation equal to 0 and then just plug and chug in your calculator. So let me know. And then I would imagine this is where it started to get confusing. Using this formula. Oh, wait a minute. Finding the vertex. Okay, so let me do it this way. We found the vertex, so we then went into parabolas. And actually from here on out, I am actually going to do a video for everybody on this last part, because some people are just confused on like chapter 18. So I'll stop right now, because that's 45 minutes that you have to watch me or listen to me yammer. So let me know which part of this video doesn't make sense, or ones that you need more practice at.